In this lecture, we're going to examine position sensors for haptic devices, because in order for a haptic device to work, you need to be able to know how the person is moving it. So there are many sensor types that are available for robots and haptic devices. They include magnetic, optical, acoustic, inertial, and mechanical types of sensors. In this class, we're really going to focus on mechanical sensors because these are what are typically integrated with an actuator on kinesthetic haptic devices. And in our case, that mechanical sensor is going to look like this. It's going to be a mechanical tracker. That is, it's a ground-based linkage. So when we talked about the kinematics of the haptic device, that is how the motor, which is also where the sensor is attached all the way to the haptic interaction point, that's a set of linkages. There's a physical transmission, and that's what makes it a mechanical tracking mechanism. But of course, the linkages themselves don't tell you anything about how they're moving, and so you have a sensor, in this case one that's attached to the other end of the motor, that measures a joint position. And there are different types of joint position sensors. For example, there are digital position sensors. Optical encoders are very commonly used for haptic devices because of their high resolution. And there are also analog sensors, such as magnetic sensors and potentiometers. And we'll start by talking about magnetic sensors because that's what we use in HapKit. But I'll also discuss optical encoders and potentiometers because if you wanted to add sensors to your HapKit or design a new device, it might be likely that those are sensors that you would choose. So let's talk about magnetoresistive or MR angle sensors. So you can see on the back of your HapKit a little sensor and integrated circuit that looks like this. It looks a little bit strange, doesn't look like your typical chip because it actually has two parts to it, and you can see this on the back of your HapKit. It's got the sensor itself, the part that measures the magnetic field through the sensor, and then that information gets translated to a little built-in integrated circuit, which is this component here. And then these leads provide information directly to the HapKit board. So these are soldered onto your HapKit board. So how does this MR sensor work? Well, the sensor uses a special magnetoresistive material, and it's a material which changes its electrical resistance when an external magnetic field is applied. And because you have a magnet which is attached to the end of your motor, and that magnet rotates when your motor rotates, this sensor can measure that rotation because there's a changing magnetic field as the motor rotates. So in this case, the resistance is going to depend on the angle between the magnetization vector of whatever the ferromagnetic material is, in this case the magnet that's just stuck on the end of your motor, and the direction of the current flow in the circuit. And so the resistance will be largest if they're parallel. Now, we don't really care so much about exactly what is the low-level functionality of this circuit because we're going to calibrate it. We're going to say how much voltage will be output from the sensor for a given movement of your HapKit end effector or haptic interaction point. Inside the sensor, if you're curious, there are often 4 sensors which are connected in a Wheatstone bridge. And if you've ever worked with strain gauges before, you're probably familiar with this technique for helping to reject noise and the effects of temperature. So the MR sensor on your HapKit board looks like this. So hopefully this should be familiar from the last slide. The MR sensor itself, and then there's the magnet, which is on the end of your motor shaft. And the exact placement of this magnet with respect to this MR sensor doesn't matter too much for your HapKit. It needs to be close enough, but not too close, so that you get a good range of resistances and therefore voltages changing through your MR sensor. But we are going to go through a calibration procedure for your HapKit so that, because every HapKit, people are going to be able to push in this rapid prototyped or 3D printed magnet holder a slightly different amount onto the motor shaft. This is the motor shaft inside right there. And so we need to be able to do a calibration procedure to account for small differences. We're not just going to assume a particular magnetic field going through the MR sensor. Instead, we're going to do a calibration.